Okay, I'll be back in just 2 seconds.
Uh-oh.
Gotta keep track of the potatoes.
I'd worked through all the questions. I was over at the math lab, and then I forgot to email the document to me, so I don't have it.
Oh, I hate that.
I realized it right after I closed all the programs. I'm like, oh, I didn't even send that to me. So that was after the test, and I was just like, you know what? I don't even care anymore.
Right, I bet. The heck with that, right?
Yeah.
Well,
But yeah, pretty interesting chapter, just going over the different types of hypothesis and errors and whatnot.
Yeah. Yeah, I think the thing that I still have a little trouble is the p-value. I'm still like a little confused on that.
Yeah.
I thought that 5 was kind of funny because it said the hypothesis test for a single mean, and so I just put z equals x minus mu over sigma, but then the answer key said it was x bar. You know, that one for, but that isn't that for sample means? When you've got multiple, like multiple. Megan, can you help me on that one?
So usually the I'm trying to
Write down.
usually that's what I would think as well, but from now on, basically we're always going to be using this formula as long as we have been given a sample size. So I don't think they should have said a single mean. That kind of throws it off.
Yeah.
Okay, so when I watched the video, the thing that made sense in my head was that when it says test statistic, they're talking about finding a z-score.
Yes.
Okay. Test statistic means a z-score. Okay.
Yeah, so that's what helped me figure that out in my head.
Okay.
Later on, though, in different units or even in different chapters, we're going to be using other test statistics other than a z-score. So I think they're just trying to get you familiar with the term test statistic, but it's not always going to be a z-score.
Oh.
Okay.
But for right now, it is.
I was really hoping we'd learned everything we needed to learn in this first section. Dang. No such luck.
Have we used p-value before?
We talked about it.
Okay.
Yeah.
So in the past, whenever you're trying to find the probability of a certain thing happening, that's the p-value of that.
Oh, okay.
Basically.
Gotcha.
So the p-value is like the area when we use that applet?
Yes.
Okay.
Oh, okay. That's good to know.
And now we're just taking it a step further and doing more things with it.
Right.
Love step furthers.
Yeah.
Okay. Any other questions before we start on part 2?
I'm sure we'll come up with lots of new ones for part 2.
Alrighty. Okay, so we'll start then with part 2. Number 1 says the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. A, determine the null and alternative hypothesis. So the null, I would think that the null hypothesis is that the score or the mean scores are 529. Is that the null hypothesis?
Yes.
Okay.
So the alternative would be, so he thinks they've improved.
Yeah, so that would be the alternative, right?
Mhm. So yeah, the null would be the mu equals 529, and the alternative would be the mu equals is greater than 529.
I was about to write the HA is greater than 529.
Yeah, that's what that is.
It's the same thing?
Mm-hmm.
Okay. Is it more correct to write it out mu? Or
Well, mu is just the mean,
yeah.
the population mean.
Yeah.
So the alternative hypothesis is that the mean will be greater than 529.
Okay. All right.
You go next.
Okay, I can. Okay.
So suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of the student taking the exam is still 529. What type 1 or type 2 error was committed? So the student, they still got the result, so they committed a type 1 error because, if I remember correctly, what is it?
They rejected the null, right?
Yeah,
They rejected a true null, right?
they rejected a true null.
Yeah, I'll do. Oh, I'll do C. So if the analysis was done at the A equals 0.01 level, what is the probability of committing a type 1 error? That is
Wouldn't that just be like a 1%?
is that the level?
So that's like an error rate of 0.01. So if you were to look at that as a percentage, that would be like just 1%, or like 1 out of 100%, or yeah, 1%.
Okay.
That's what I got.
Is that right?
Yeah. Also, another way of thinking about this is that the probability of a type 1 error is always going to be equal to this alpha value.
It's equal to its alpha value. Okay.
Mm-hmm.
So Amy's turn.
Okay. If we wanted to decrease the probability of making a type 2 error, we would need to increase or decrease. Would we need to increase or decrease the level of significance? So the level of significance is the little, what's it called? The little A thing?
The alpha.
The alpha, right?
Mm-hmm. Yes.
So if I remember, you have to go the opposite way. So if you want to decrease that, you have to increase the level of significance.
Yeah.
Right?
Mm-hmm.
And isn't it? So if the value is very small, the chance of a type 2 error is large. And if the probability of committing a type 1 error is low, that's oh, if the value is large, but a low chance of a type 1 error and a high chance of a type 2, is that right?
Yeah, so as the alpha value, the level of significance decreases, the probability of a type 1 error also decreases, type 2 increases. They have an inverse relationship.
Okay.
And either way requires.
So, did you say, Amy, that the level of significance increases?
Yes. Just have to do the opposite to make it balanced.
So the evidence is
All right. Is it my turn?
and then
Okay. A study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent was to determine if the average age of those buying investment property in his area is different from the national average. He randomly selects 15 of his clients who purchase an investment property and obtains the data shown.
you can't mix.
A says, design the study. What is the population from which the realtor obtains his data? How did he sample this population? What is the research question?
But yeah,
Okay.
just go through and
So, what is the population that he got it out of? Is that like the population of the whole nation?
I think it's more like the population of just the home buyers.
yeah, there's a couple of them.
Would it be second home sales, like second home buyers? Would that be the population?
Yeah, that's
Yeah,
that's what I think.
Because
Okay.
you wouldn't include first home buyers because it's only second home, it says, right?
Yeah.
Okay. Sample.
Easily,
Okay, so is it just simple random selection?
even being able to
Let's see. But they're also his clients, so doesn't that kind of make it a convenient thing?
Oh,
It doesn't really give us enough information to know for sure which sampling method, but we know that he randomly selected his own clients.
so it is simple random.
another
Not necessarily, because simple random is that the entire population has the same chance of being selected, and for him, he's only selecting his own clients. So we really don't know exactly what sampling method was used, but we know it was randomly selected from his clients.
They're not asking for one of those types, just
No,
what to-
not yeah.
It's, okay, so it's asking that he got it from his clients.
Yes.
So his 15 clients are the sample?
Yes.
Okay.
What is the research question?
So the research question is if the average age of those buying investment property in his area is different from the national average. Or is it different from the national average?
Yeah, that sounds good to me.
Okay.
Alright, so collect the data. Name at least one way the realtor could have collected randomly selected samples. So, let's see. Well, we know he could have used the simple random sample. He could have used a stratified sample, right? Dividing people into similar groups by separating them into just people that are second home buyers. So I think those are the two types that he could have used.
We describe the data, graph the data on a histogram, sketch the histogram below, or cut and paste your electronic copy. In a short paragraph, describe the data using at least 5 descriptive statistics. So, I have to go into SRSS, and we can't do that and stay on this Hangout.
Yeah. So yeah, you go into yeah, I can't do that either from here. But yeah, you go into the program, you put the data in, have it calculate. It give you a histogram, it give you all that, and then there's a program on the school computers that lets you copy the graphs and stuff like that directly from the program, and then paste it into a Word document.
That program, is it the snipping tool that you're talking about?
Yeah, yeah.
It's on most computers. If you want to just like search for it, like I didn't realize I had it on my computer until I took the class, and then it's there for most
Oh my
computers.
gosh, it is on my computer.
Hooray!
Where do you search for it?
You just type snipping tool, and then it'll come up.
When I did it, it just let me do it without even having to really access the program. I just copied and pasted
Yeah, that would work too.
without even knowing what I was doing. Not knowing it was special.
Oh, that's cool.
And you guys should be able to open up VMware while you have the Hangouts open as well.
Yeah, but what happens is all of a sudden it will take you to the school desktop, and it won't let you access anything on your personal computer, so you can't see or anything.
Oh, you can minimize that screen. If you want, I can screen share it, because I have VMware open right now. So I can show you.
Oh, perfect.
Yeah, so
If you want, I can do that real quick.
That'd be great. We haven't had to input data into SRSS yet, have we? We've just been using tables of data that were already generated.
I think so, for the most part.
Yeah.
So it'll be good to kind of see how we do that.
Okay, so I'm
Trying to
going.
open it here too, but it's taking forever.
Okay, so this is what it looks like whenever it's full screen, and then up here there's the there's minimize and maximize. Oh, push that, and then you can.
oh, I didn't even see that.
Well, that's handy.
Good to know. Good to know.
It makes it so your screen can be super cluttered though, because a lot of times you have like 5 sites open at a time, and
Mhm.
and then printed that for you.
By the end of the semester, we'll know all the tricks, guys.
I know.
I didn't care about it. Took it out.
Yeah.
But you filled it out, so I was like, oh, it's great.
Now you're.
Wait, so Dustin, what did you say for collected data? Did you just say it was just simple random, or what else?
I said it was either simple random or
Gratified.
stratified.
Okay.
Because it's not a cluster. I mean, even though that's, and it's not a convenient sample.
Okay.
So, and it's not a systematic sample. So that just kind of leaves the other ones.
I guess he could do a systematic sample if he wanted to.
But that one is like.
He could have all the different people lined out and just say, okay, I'm going to take every 10th one.
100. Yeah, I guess you could do that.
Not what he did, but if you could choose to do that.
And then for the SPSS, how do we put the data in and then make it into a histogram?
So if you open SPSS, it should just come up with a blank data file. If you just enter in those numbers, and then do the graphs, legacy dialogues, histogram like you would for another set of data.
Oh, I thought you were pulling that up to show us, Megan.
Yeah, I can do that.
Okay.
Thanks. Okay. So, I can start over so that you can see from the beginning. So open up SPSS. And then just take the numbers over here and type them in: 27, 35, 48, 49, 55, 58, 56, 50, 51, 45.
Oh, David, you're presenting to everyone.
What's that?
I think it got stuck on your screen instead of Megan.
Oh.
It says David is presenting to
Oh.
everyone. You are no longer presenting.
Oh, perfect. That's what that is.
Okay. So yeah, now you have those numbers, and you can graphs.
But I
Legacy
don't see
dialogue.
yours, Megan. Does everybody else see Megan's screen?
No, I can't see hers.
See it.
I can.
Now does that work? Can you guys see my screen now?
Try clicking on her name and it should pull you just to her screen.
No, I just see Hawaiian trees, palm trees.
Interesting.
I see the charts.
Oh, now I see it.
Okay.
I just see Hawaiian trees.
Maybe it's lag.
Maybe. Clicking on the screen doesn't seem to be pulling it up for me. Like I can see it in the miniature down the thumbnail, but how do you pull it up to be full screen?
If you click on the miniature one, then it should just bring up the person's screen that you click on.
I wonder why it's not doing that.
I'm not getting it either.
That's interesting.
Oh wait, maybe now I have something.
Did you just click on it, Amy?
Yeah, I see the same thing, Tara. Like it when I don't click on her name, I can tell that she's sharing it, but then I click on her and it's
You
not.
just have to wait a little bit. There's a little bit of lag. So like it'll be black screen for a bit and then eventually it will pop up.
So
Yeah,
then,
'cause I just clicked on her name and then it like changed.
so you're just putting it in one row, like one,
Yeah. Just put it in one
22nd,
column.
249. Okay.
Well, that's enough to do.
You don't have to highlight it to use it.
You don't have to. Sorry, what was that?
You don't have to highlight it to use it, or do you?
Highlight what?
Your data
Excel.
when you go over to the.
Oh no. When you do the graph, you don't have to highlight it.
Okay.
Okay,
You'll
so
just select the variable that you want, and it will know that that's the.
Okay.
so I plugged in all the numbers, and then do I just go to Analyze, Descriptive Statistics, and Explore?
Yeah, that would give you the descriptive stats, and then you'd also need to make a histogram with the graph.
Okay. That's under plots, right? Does it matter if I put on their box plots dependents together or factor levels together?
It doesn't, no.
Okay.
So it says it wants us to use at least 5 descriptive statistics that mean it wants like a 5-number plot or 5-number summary?
Or it could be like the mean, the standard deviation, the minimum, the maximum, and let's see, one other number, the median. And that would be 5 numbers.
Any old numbers, huh?
Mhm.
Okay.
But you could use the 5-number summary, and that would still be 5
Yeah.
statistics. Then.
Okay.
Do you guys still want me to be screen sharing, or?
So did you get this, Megan? Is this right?
Yes.
Okay.
So
Sweet.
what does make inference mean? Oh, is that the steps it takes us through?
Yeah. Then you go through 1, 2, 3, and 4, 5. Well, there's 7 for make inferences.
Okay.
And I think that the key might be wrong for at least one of these answers.
Oh, really?
Mm-hmm.
So I don't remember who we're at, but
Did we get the 5 numbers for the 5 different descriptive statistics on C?
there was 5 of those, David.
Oh, the 5 numbers. Is that the 5-number summary? Is that
We can
that?
pick just any 5 statistics from the chart. Do you want those to be mean or median or any of the quartiles, any of it?
Okay.
So it could be the 5-number summary, that'd be fine.
Okay.
Do you want to give us those? The 5-number sounds good.
Okay, I can give you. Okay, the minimum is 27, and then the mean is 46.73. The median is 49. Standard deviation 8.827. Maximum is 58.
What do you do, Bob? Do we have to write a short paragraph about that? We can,
I think that you can pretty much just say, you know, the mean is this, the standard deviation. I don't know if it's really a paragraph that they're wanting about.
so I think we got that.
All right. Are we on to D, right?
Yeah.
Make inference. Check the requirements. Since there are only 15 pieces of data, what will you need to check?
See if it's a normal distribution.
And how would you check that?
Why don't you just make one of those cool little charts?
Mm-hmm.
Do we have to do like a QQ chart, or can we just like look at the shape of the?
Because if we can look at the histogram, we should be able to see if it's skewed or normal, right?
Sometimes, but to check to make sure, you need to check the QQ plots.
Okay.
Okay, hold on. I'm trying to make one right now.
There it is.
Look at there.
That looks normal to me.
Yep.
Yep.
Okay.
Good job, David.
Thanks. So now are we under 2?
Is that all you need to check? Is just to see if it's normally distributed?
Yeah, there's 3 things to check to see if it's normally distributed. The first thing is the parent population, the second thing is the sample size, and the third is QQ plots. Since it doesn't tell us anything about the parent population being normal, then we have to go to the sample size. The sample size is too small, so then we go to the QQ plots.
Okay, perfect.
So 2 is state the null and alternative hypothesis. Is this a 1 or 2-tailed test? So state the null and alternative hypothesis. So the null hypothesis is the national average, right?
Well, I think it has to do with like the mean being
Yeah. So the null is average age of a person buying a second home as an investment. Rental property is 47.
So then it would be like, would it be do the symbol HO, and then you do the mu symbol equal 47? Is that how you'd write it out?
Yes.
Okay, so
And so then the alternative would just be opposite of that, basically. That would be the mu symbol, but it would be not equal to 47.
Exactly.
Okay.
So it's a 2-tailed test.
Mm-hmm.
The 3 is let A equal 0.05. That's not really anything for us to do, is it?
No, it's not.
Just giving us some information. Perfectly willing to let A equal 0.05.
What is that again? Is that the test statistic?
No, that's the level of significance.
Oh, that's right. Okay.
I just wish these questions were more straightforward.
The test statistic. So we go back to that z-score formula.
Yes.
Yes.
Z equals x bar minus 47 over, we don't have sigma.
No, it'd be over the standard deviation, right?
Yes.
Does A become this? No, it doesn't.
And then does this one has a number, right? Or a
Standard deviation is 5.
Oh, it does. Oh, it was in the problem.
Yep.
and then does it have a sample size?
15?
15.
So then it'd be x bar minus mu over standard deviation over the square root of the sample size.
Mm-hmm.
So do we know what x bar is?
Let's see.
So x bar would be the sample mean, the mean of all the 15 that he sampled.
So we'd add all those together and divide it by 15, and that's the x bar.
Which we had the mean from.
From that chart.
Yeah, which is 46.733.
Yeah. So we got 40. Subtract 47. The standard deviation was 8.827, right?
Yeah.
Oh, so we have to take the standard deviation from this study, not from the national study. That where I almost got in trouble?
Wait, is that what we're doing? Are we getting the standard deviation from the sample or from the national?
Because they're different.
Yeah.
That's a good question.
So the standard deviation from the sample, did they get that one by doing the, remember the equation where it's the standard deviation divided by the square root of the sample? Is that how they got that one?
I
No,
think
because
one's
five.
the nationals. Go ahead, Megan.
Oh, sorry. It was 5 divided by the square root of 5 is 1.29, not the 8.827. And usually you would use the population standard deviation, not the sample standard deviation. So I would use 5 for this one.
Okay.
Okay.
That's tricky, though. How do you know for sure?
There's just never a time that we use the sample standard deviation because we want to have the most accurate standard deviation. So if it gives us the population standard deviation, that's what we're going to use.
Okay.
What everybody did.
Just starting.
So I got negative 2068 as the z-score.
And I got negative 0.209.
So because I did the 46.773 minus 47
Yeah.
over the standard deviation of 5 divided by the square root of 15 because that's the sample size, right?
Yeah.
How did you get the 0.209? What did you do?
I did 46.73 minus 47, and that gave me it was negative 0.27, and then divided that by 5 divided by the square root of 15, and that gave me so 5 divided by the square root of 15 is 1.291. So negative 0.27 divided by 1.291 gave me negative 0.209.
Okay. So I didn't round my mean. I kept 4 decimal places, and I got 0.206. But then I did it like you, and I got 0.209. So
I got 0.2206.
Missing something.
Yeah. It's one of those rare cases where the rounding really matters.
yeah.
I just used this.
Yeah. And what was yours, Dustin?
It was negative 0.2068173111.
Yeah, that's what I got.
So that was with no rounding.
And usually the key will have the one that there is no rounding, but in this case they only did the one that was rounded, which is odd.
Super.
But I'm glad that you figured that out, because yesterday I was with the group and I'm like, I don't know how the key got what they got, and I think it was, yeah, so I'm glad I can figure that out. Now I can send them an email saying, hey, I figured it out, or you figured it out.
That was
I'm curious. Let's delete that. Okay. Yeah, so by deleting one of the decimal places, it gave me -209.
Mm-hmm.
So is it
okay.
better to get rid of those decimal places, or is it better to put in all the?
Usually you want to keep as, you do not want to round before you get your answer. You want to keep as many decimal places as you can.
Okay.
In this case, though, the key rounded before.
So the key's teaching us the wrong way to do it. Basically.
Yes, basically.
So now we got to use the applet.
Mm-hmm.
We have to find the applet.
I bookmarked it so I could find it easy.
So my office hours start at 1, so I'm going to open that up, and if people come in, I'll have to be in and out, but I can still stay on and help you guys if people don't come into the office hours.
Okay.
Oh, we lost Tara for a little bit. So do we put this number that we just got for the z-score, we put that into the applet, right?
Yes.
Okay.
Oh, we finally decided on 0.2068. Was that right? Or no?
Well,
What was the most accurate?
0.206 is the most accurate.
Okay.
Okay, and what are we shading?
Because this is not equal to, you'll shade both sides, both ends.
Oh, okay.
leave the middle blank, right?
Mm-hmm.
That's 0.8368.
Yes.
Because it is not equal to.
So then the p-value is 0.836.
Or 37 then, right? Oh, when is... These decimal points are a pain in the tush.
Yeah, they are.
Because I got 0.6.
Is this right, Megan?
Yeah, this is right.
Okay.
And since it's the prep, it really doesn't matter if it's a couple of numbers off. You won't be turning it in or anything. So.
Do they try to get more even answers on the tests and stuff?
Yes, yes, for sure. Or they'll have it across the board of make sure that you don't round before you get to your answer and
Yeah.
that kind of thing.
Alrighty. Shall we move on?
Yep.
Do we still have any questions?
So
Are you
that
good,
was,
Tara?
I'm just wondering what answer we're putting down. So this is.
If you look at if you look at the applet, we put in the z-score, which is the answer we just got from the previous question.
Mhm.
And then
so
the value.
The test is okay. So the test statistic was the z-score. So that's the answer for 4.
Yeah.
And so 5 is the p-value, which is the probability, which is the 0.836. That
Yep.
was you. Okay. So 7, no 6.
Yep.
All right.
To the level of significance.
So if you look at, because the probability is 0.83 or 8, whatever we said, 86 or
0.836.
yeah. And the probability or the what is it? The significance thing is 0.05. Then it's greater than it. And since it's greater than it, then we would fail to reject the null.
Fail to reject the null, in other words, confirm it.
Yeah.
Yeah.
I know, it's so backwards.
Except that we can't actually say, oh, it's right, because we don't know for sure. But we can say that it's not wrong, as far as we know.
That's
not,
why.
But it's not right.
It's
Not wrong.
Is that why? Is that why it says fail to reject? Because of that. Okay.
Okay.
That's so lame.
So the last one here is take action, and that's the end of our. We still have a quiz to do too, or is this it?
Yeah, we do.
Yeah, we do.
Quiz to do?
The quiz is much easier than
That's good to know.
I'm gonna have to step out to get my little dude to kindergarten. So I guess continue on, and I'll be back. Okay.
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 Alright.
What action, if any, do you suggest the realtor to take based on your statistical conclusions? No?
I tell them to keep doing what they're doing.
Yeah.
So if we failed to reject it, then maybe he should target people who are the whatever age it was, 47?
Yeah, keep targeting those same people.
Yep. Okay, sweet. Shall we move on to the quiz?
Oh, let's.
Okay. Alright, so the first question, a hypothesis test consists of 2 hypotheses. The null hypothesis and the alternative hypothesis. Which one represents the status quo? I think the status quo is the null hypothesis, is that right?
Yes.
Okay. Dustin, you want to get the next one?
Which hypothesis involves equality? So, it's the null hypothesis, again.
Yes.
Because the alternative would be less than, or not equal to.
Yeah.
Right.
Yep. That's right.
See, they're already trying to trick us up. And it's only
All right. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. when computing this probability, which hypothesis do you assume to be true? Null hypothesis or alternate hypothesis?
P-value is the probability of obtaining at least as extreme. Oh, I just saw that.
I'm not sure on that one.
Okay, so that is the null hypothesis.
Okay.
That
If
says
we
that
always assume the null to be true, it's the innocent until proven guilty kind of thing.
Okay.
Oh, that's a good way to put it. Okay, suppose the null hypothesis is that equals a 10. Use this information to answer questions 6 through 8. Which of the following represents the alternative hypothesis for a two-tailed test? Man, these tailed things.
That's the not equal to. Right?
It's the not equal to?
Yes, that's right.
Okay, can you explain a little more on the whole two-tailed test
Of course.
part?
So if it's two-tailed, that means that we have the mean in on either direction, whether it's less than or greater than.
Okay.
Not going to be equal, but it could be either less than or greater than. With one-tailed, it's either going to be just greater than or just less than.
Okay.
So like a two-tailed, would that be when you highlight both sides of the thing
Exactly.
and leave the middle blank?
Mm-hmm.
Okay.
Oh, okay. Got it. Cool. That's in your app.
Okay, which of the following represents an alternative hypothesis for the left-tailed test? For a left-tailed test. So that means, would it still be, let's see. So, would it be one of the greater or less than ones? It'd probably be, mean is, if it's left, then it's less than. So it would be the first one.
Yep.
That makes sense. So then the next one would be the second one down.
Yeah. The mean is greater than 10.
Greater than 10.
Okay, that makes sense. Yeah. Okay, the outcome of a hypothesis test is determined by comparing the p-value to the level of significance. Use this information for questions 9 through 10. Which relationship would result in failing to reject the null hypothesis? So if the what is it that we just talked about that has to be above or below 0.05 that we just talked about?
The level of significance?
Okay, so that's the level. So the p-value has to be above that to fail to reject it?
The way that I remember this is if the p is low, you reject the null.
Okay.
So if the p is below the level of significance, then you're going to reject the null hypothesis.
Below, reject the null. Okay. And so then it would be the first answer, p-value more than?
Yes.
Okay.
So which relationship would result in rejecting the null hypothesis? It'd just be the exact opposite. It'd be p-value is less than the sigma. Is that what that little a thing means? Is sigma?
It's alpha.
Alpha? Okay. What's the sigma thing?
Sigma is the standard deviation. It's like the
Oh, yeah, okay.
0 with the line, or the O with the line.
Okay.
Tilde 6.
All right. The insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim amount was $15,000. They are concerned that the true mean is actually higher than this. Use this information for 11 to 12. Which of the following would be appropriate? Would be the appropriate alternative hypothesis? So it would be the average claim amount is greater than $1,500.
Yep. Yep. And then which of the following would be the appropriate null? The null is equal to $1,500. The average claim.
Yeah.
Okay.
The insurance company randomly selects n equals 40 claims and calculates the sample mean of x bar equals 1,650. So use that for the next ones. So the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? What was it? 30? Did the sample size need to be above 30 for it to be considered a big number? What
Yes.
was? Okay, so then yeah. So it's above 30. So
it's yes.
Okay.
And then what theorem or... Oh, sorry. Did I skip you, Amy?
I don't know. Go ahead. I'll do the next one.
Oh, okay. I was just gonna, okay, it's... what theorem or law justifies your answer to the previous question? That is the law of large numbers, right?
It's actually the central limit theorem. The central limit theorem has to do with shape, and so if it's talking about the distribution of normal, that's the shape, and that would be the central limit theorem.
Oh, okay. So whenever it just talks about distribution, it's always the central limit.
Yes.
Okay.
The law of large numbers is spread. It's talking about how as the sample size gets larger, the standard deviation is going to get smaller, and the sample mean will get closer to the population mean.
Okay. Awesome. Thank you.
No problem.
Okay, which of the following is the test statistic as defined in this lesson? And that's C.
So is it Z?
Yeah.
Okay.
is Z supposed to represent the Z-score?
Yes.
Okay.
So when it's talking about test statistic, it's just Z-score.
Gotcha.
For now. Later on, we're going to
For
have
now.
other test statistics, but for now, it's the.
Oh boy. Okay. Wonderful.
Not confusing at all.
Who's up? Whose turn is it? Is it Dustin's turn?
Go, Dustin.
Okay. So the historical mean of sale receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up the hypothesis test with the following hypothesis. So the null is the mean is equal to 150. The alternative, the mean is less than 150. So she will use a significance level or a level of significance of 0.05. She then takes a sample, simple random sample of 36 sales receipts from the store and computes X equals $144. Use this information to answer the first. So what is the Z-score associated with this test. So round to the nearest 3 decimal places. So, well, we have the M is 150, the standard deviation is 40, and the X is 144. So it'd be come on, turn on. So we have 144 minus the 150 divided by the standard deviation of 40. That's divided by the sample size, wrong button, which is
is it 36?
36 receipts. There we go. So that gives us a z-score of negative 0.9.
That's what I got.
So this is where I ran into problems on the test because, like, okay, the calculator, it only gives me 1 decimal place over. So I thought to get the right answer, I'd have to add a couple zeros to that. So would that be right? Does that sound logic, or am I going to get it wrong for doing that?
To be on the safe side, always add zeros to get it to 3 decimal places.
Okay.
Oh, really? Dang it. Okay.
So then it's negative 0.900.
Yes.
Okay. What is the p-value associated with the z-score from the previous question? So that's where we plug it into the applet, right?
Yeah.
Okay, and since we're looking for less than, we shade to the left.
Yes.
Okay, so then the area is 0.184. Or, I'm sorry, the p-value. Okay, Amy, you're up.
Okay. What inference would you make about the null hypothesis for this problem? This is where I get so confused. Okay, so the level of significance is 0.05, and the p-value is 0.18. So we would reject it?
What did,
I thought we would, if it's greater than the significance level, when we fail to reject it.
Yeah, if it's yeah, okay.
Oh, if it's well, ugh. See, this is where I get confused.
When the p is low, you reject the null. So the p is higher than the level of significance, so we're going to fail to reject the null hypothesis.
Just remember that cute little rhyme, Amy. When the p is low, you reject the null.
I'm gonna have to make up a little song for that one. I gotta teach my kids stuff with this song.
There are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I believe that's type 1. Right?
That's right.
Okay.
Good job, David.
So a researcher decided that instead of using a level of significance of 0.05, he will use a level of significance of 0.01. Which of the following will be true? So the probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability of null hypothesis be true will decrease. I think it's the first one. Because the smaller the level of significance, the less likely, the more likely there'll be a type 1 error.
That's what I think. Is that right, Megan?
It's actually not, but it's easier for me to explain this question if we go ahead and answer 21 first.
Oh, okay. So if level of significance equals 0.05, compute the probability of committing a type 1 error.
Wouldn't that be 5%?
But it's just 5?
The 0.05.
0.05.
That's the answer? It's just 0.05?
Yep. Because alpha, the level of significance, is always the probability of committing a type 1 error.
Oh.
And then going back to 20, the probability of committing a type 1 error and the probability of committing a type 2 error are inversely related. So as one goes up, the other one will go down, and vice versa. So the level of significance is going down, so the probability of a type 1 error is decreasing, which means the probability of a type 2 error is increasing.
Oh, okay.
Okay. So as the level of significance goes down, the type 1 error goes down as well, but the type 2 error goes up. Okay.
Yes.
And be sure to add a 0 after that last one. It should be it should be 0.050, right?
Yeah, to be on the safe side.
Okay. I'll volunteer as tribute.
Ah, we got them all right.
Yay!
They should let you do exams this way where you can bounce ideas off people.
That would be a really great idea.
Awesome. Thanks so much, Megan.
Oh, no problem. Do you guys have any other questions?
No, those are pretty much it, the ones I had.
Okay. If you guys ever have any other questions, please feel free to come into the office hours or send me an email. Some people even send me text messages with random questions. So please ask your questions. I want to help you guys and have you all make hundreds on all the tests.
Sweet. Awesome. Thank you so much.
No problem.
Thank you.
Okay, so guys, do I just press stop broadcast and then